But now, I mean, it's recorded.
It's recorded.
So you
Yeah.
can put the social media and that.
Do they ever use the recordings? You know?
I don't know. They must. They must, but I think the big thing is you can use it.
Okay.
Yeah, you can just get it, rip it off.
Give me
YouTube.
access. Yeah.
Well, I think it's just sitting on YouTube.
Oh, I see.
And you can really, without too much effort, you can pull it off YouTube.
Right.
And clip it up and use it for your own social
Yeah.
media. We're going to do that.
Yeah. Okay.
Anyway, we should, let me pitch an idea, an easy idea to you.
Right.
We should treat this as warm-up for you coming on our podcast.
Perfect.
Right on?
Yep. Yep.
And, okay, let's see if everybody shows up if we start. Good morning, Hall 7. So, very excited to kick off day 3 of Hannover Messe with my good friend Vivek all the way from Markham, Ontario. We're going to hear from Vivek about CyberWorks robotics, about some of his experience at the University of Toronto developing autonomous robots, about collaborations with NGen, about collaborations with Linamar, and with the future of autonomous robots. So, Vivek, welcome.
Perfect. Glad to be here.
So how have you been enjoying the conference so far?
Fabulous, fabulous. We've had a lot of traction here, a lot of interest in our technology, and I think it's a great place to showcase the innovations we've made in the industry.
Any highlights? Any one highlight so far, knowing that we're only on day 3? We've still got day 3 and day 4 to go.
No single highlight, but I think we've had very productive meetings with, some of the biggest brands in the world are here. IFM, Bosch, Dell, they're all here, and we've had fantastic meetings with all of them. They all see the value in the technology that we've created, and they're all blown away. So that's a great start.
So tell us a bit about yourself and a bit about your company, CyberWorks.
Sure. Yeah. About myself. My background in autonomous mobile robotics goes back to the very earliest days of the field. Back in the 1980s, when Geoffrey Hinton at University of Toronto was starting to build neural nets, there was another group, lesser well-known. Well, even Geoffrey nobody knew him that time either, but even perhaps lesser known. There was another group at the University of Toronto under Professor Casey Smith, who is the chairman of electrical engineering. Another researcher, another student that was writing the first thesis paper on autonomous mobile robots for dynamic indoor environments happened to be me. And that's how the industry, that was one of the first first serious attempts at developing autonomous robots in the world, and led to where we are today.
So funny enough, I was growing up in Toronto in the 1980s at the same time. My recollection of Toronto in the 1980s might be a bit different than what was happening at U of T. What was the mood? What was the vibe? What was the spirit at the University of Toronto, at Canada's largest and we'll call it tied for its most well-known school? What was the mood in and around campus those days with all this stuff coming out, with Geoffrey Hinton kind of inventing AI?
Yeah, well, to a certain extent, it was euphoric, or at least as euphoric as Canadians can get. From our work, from our academic work at the university, we then launched the world's first autonomous mobile robotics company. We were first in the world to do that, and we had a tremendous amount of continuous global press, global publicity, which again was very unusual for a small Canadian company. Just didn't happen back in those days. So I would say it was really euphoric. I mean, the whole world was knocking on our door, literally. I mean, actually flying in, researchers and industries flying in from Japan, from Europe, from Germany, into Canada, into Toronto, to our little startup back in the 80s.
What street? Were you on campus or were you off
No,
campus?
we were off campus. I grew up in a small town north of Toronto called Orillia. Nobody's ever heard of it, so don't worry. But we were actually there, and it was funny because all of these global companies would come into Toronto, and they would come in just to see us and drive to this tiny village north of Toronto.
Fans of Gordon Lightfoot might have heard of Orillia.
Yeah,
I think so.
Exactly. That's exactly it.
And I heard, before we wrap up the origin story, I heard that there was a famous Toronto Star article featuring you and your company.
Yeah, many.
A lot of articles.
Many, exactly. Yes, we were in the paper every other day, almost, and Toronto Star covered us. We were on the cover of the Globe and Mail and New York Times, Washington Post, and so on. So it was really a big deal. I mean, today, mobile robotic companies are popping up almost a dime a dozen, but in those days it was a pretty big deal globally.
What are you up to these days?
Even more exciting. I think the biggest problem that we've seen in autonomous mobile robots across the years, since those very early days in the 80s, right up till today, is the prevalence of what we in the industry call edge cases. So, people ask, well, what have you been doing all these decades? Because I don't see R2-D2s running around everywhere. Where's the robot revolution? Why don't we see robots everywhere in society bringing us coffee at the office and all that sort of stuff? And the biggest problem in the industry right now is what we call edge cases. These are unpredictable situations in which an autonomous mobile robot will fail. Robots will lose localization, meaning they don't know where they are suddenly. They will get stuck. Things like that will occur occasionally. I was walking through the Hannover Messe yesterday, taking a bit of a tour, and I went over to the SAP booth in the other building, and SAP has 3 autonomous mobile robots running around in this little corral. All 3 of them had stopped working. It was so funny. It looked really bad, but it was funny in the sense that, these are the edge cases that we keep talking about. And until these edge cases are solved, you're not going to see the robot revolution happening. This revolution that the media keeps talking about and you keep reading about, it's not going to happen until we solve these edge cases. So what we've been doing at CyberWorks all this time has been to try and solve this problem of edge cases in autonomous mobile robots. And last year we succeeded in doing that, and that's why we're able to talk to companies like Bosch and Linamar and IFM, the global leaders, industrial leaders. And we're getting a lot of traction because now that we've solved the problem of edge cases, robots don't robots have become reliable. They're not doing what we saw in the SAP booth yesterday. They're not stopping and getting lost. And our company CyberWorks is now licensing this technology to the global players, the companies that are trying to build billion-dollar-a-year industries producing autonomous mobile robots, Bosch, IFM, and so on and so forth. So it's a very exciting time for us because for the first time in history, we're going to be enabling the robot revolution, solving the last missing piece of the puzzle so that we can finally start to see robots in society.
What are some of the first steps that you're taking to solve these problems?
It's really deep tech. So that's like a 2-day seminar right there, right? So it's a complex process. There are a lot of moving pieces involved. There's a good reason why hundreds of other companies have been working on the edge case problem and haven't solved it yet. So it has to do. I mean, I'm not going to totally not answer the question. So my attempt at answering it is that it has to do with a series of cascading events within the perception stack, the path planning stack, and the execution stack of an autonomous robot. And it can start with something very, very small that nobody notices in the environment that can trigger a series of cascading of events that result in a robot just then suddenly getting lost for no apparent reason. So, yeah, I'll try and keep it high level there for you.
NGen is our kind of lead on this delegation, doing a great job. You have some collaborations, some partnerships, some projects that involve NGen and I believe involve Linamar.
Yeah.
What can you tell us about those?
Yeah, fabulous. It's been great working with Linamar, one of Canada's leading automotive companies. We're doing a project that's being funded by NGen, which has set up this whole Canada pavilion at Hannover Messe. We're working on a project where we're applying the same technology that I just talked about to material handling in auto parts factories, specifically in the Linamar factories where they do a lot of machining. That machining process generates a lot of waste that has to be constantly taken and disposed of from multiple workstations within each factory. So each factory might have 50 of these machining workstations. So there's a constant flow of this material out the door. That takes a lot of labor. There are labor shortages in this industry right now. And so by automating that process, we make the plants more efficient. It's an excellent use of robotic technology because nobody wants to be doing that job. And so now we have these robots running in an in a Linamar facility just south of Toronto. And it's going great, and it's a common application. Machining metal blocks is probably the most common thing you can have in an automotive factory. So it's something that we'll be able to replicate in hundreds of factories around the world.
What role did NGen play in facilitating a partnership between a small Markham-based technology company and one of Canada's largest manufacturers?
NGen is really good at helping to de-risk a research project. I don't think Linamar would have gone forward with the project despite all of its advantages unless there was somebody helping to de-risk and create a financial incentive for them to do that. So I think that's the primary benefit, and a lot of secondary benefits as well in working with NGen, in terms of just creating exposure, creating visibility for our technology, creating a first use case in a particular industry, because the toughest thing for any startup in any market or any industry is that first customer, right?
So we are into day 3, with the exception of, I know we're excited for our panel at 3 o'clock right here tomorrow with Robotape, with Dot Automation, with York Region. What's on tap for day 3 and day 4 for you? What are you most excited about to see, to hear about, to learn about, to go and experience in Hanover?
Yeah, we have a lot of meetings that we had lined up in advance, and so we're going to be continuing with those discussions. I'm most excited about, who just walks by our booth and goes, wow, we never heard about you, and we can use this technology. It's always fun to see that happen. It's happened a number of times in the last couple of days where we've seen small companies come by and say, that's exactly what we need. So that's the fun of being at a trade show like this. You never know what you're gonna get in the next hour and in the next day.
Great. So any parting thoughts, any last words for the audience before we let you get back to the business of networking?
Just a lot of fun to be here, and we'll look forward to being here next year as well.
Great. Vivek, thank you very much, and we'll talk to you soon. We have a great lineup today on the stage at Hall 7, and we'll see you again in a few minutes. Thank you, everyone.
including Industry 4.0 technologies, advanced manufacturing concepts, and the reality of connected
Good morning. Next up, all the way from Vancouver, British Columbia, Canada, Simon Fraser University, Professor of Mechatronics Systems Engineering, Woo-Soo Kim. Woo-Soo, welcome to the stage. Thanks for being here. Take it away.
Thank you, Brandon. Thank you for having me here. Hello to the audience in the online. So I want to discuss with you three things today. So as introduced, I'm Woo-Soo Kim, working in the mechatronic system engineering in SFU. So the title of presentation today is about the robotics and sensors. I'm not the guy who is developing robotics, but using robots to make useful for human being using the sensors. So I have three parts today. The first one is, of course, kind of a promotion of my own institution, Simon Fraser University. And the second is the promotion of my department, Mechatronic System Engineering. And then third is actual things I want to talk, three things today. So I brought, here we go. So manufacturing related robotics and the biomedical side related robotics research and the agri-tech related research. So three topics I want to share with you with some user cases of the robotics. So first of all, SFU, I really thank you to the German partners, their hospitality this time, and NGen for the making this journey happen. So SFU is well known, you know those numbers here. So well known with the research-based innovation success story. So we are very much dedicated in innovation, and especially in smart manufacturing is one of the topics we dedicated. And mechatronic systems engineering, we covered a major part of mechanical engineering together with the mechatronics, like sensor and actuators, smart manufacturing, advanced manufacturing, and biomechatronics. So among these topics, I want to briefly talk about smart manufacturing. So in SFU, we have we partner with Siemens, having this Siemens Mechatronic System Certification program. We are the only university in Canada having all three levels of this certification program. And also we have professional master program called the Smart Manufacturing and Industrial IoT. So this program has cutting edge equipment for the smart factory experience for our students. So if you have a chance later, I'm just skipping this video at the moment, but feel free to come in and check this video. Right, and also partnering with the Siemens, we're using Siemens NX software for the CAD and CAM. So this software has many modules to play with in the smart manufacturing topics, starting from the planning with the CAD and the simulation, and predicting any things and diagnosis, etc. So we're using this NX system for professional master program as well as undergrad curriculums. So I brought the two interesting the demo from this Siemens NX program used in the undergrad courses. We have a first year one course and a second year another course, robotic courses using this Siemens NX. So first of all, you can see in this video the robot arm holding this vehicle, robot vehicle, is moving around just on the track by having computer vision based machine learning. So student can learn machine learning, inverse kinematics from the robot arm, the modulation, and the decision making from machine learning, collaborating with the Raspberry Pi as a microprocessor inside. And if the robot detect the obstacles, then it move away and then going on again. So this is all programmed by students. This is one example of the robotics course in the first year. And by using the Siemens NX, once again, we teach digital twins too. So you can imagine this robot is physical twin, and its digital twin can be built inside of the Siemens NX interface. And this is not just the CAD, because we have synchronized, real-time synchronized between the physical twin and the digital twin. Then we have identical moving can be happen between the physical twin and the digital twin, as you can see. So sensing signal, actuation signals going into the MQTT IoT module, and then it communicate with the Siemens NX, and digital twin can actually work same like physical twin. So this is a small example, but you can imagine student can learn this and then apply to the future factory, right? Then digital twin operators just in front of the desk, they can handle the digital twin to work and operate the physical twin factory components later. So these are the education part. So these, I want to introduce these two things, and then let's change our gear into my research highlights. So I brought 6 examples of different topics for the robotics use. First of all, robot and multi-directional 3D printing. As you may know, the 3D printing is vertical stacking, so vertical fabrication usually. So it doesn't really think about multi-directional 3D printing, but we are working with this kind of the 6-axis, 6 degree of freedom industrial robot arm, and these robot arm can build stuffs from the side or the object with the curved structure by having this multi-directional 3D printing. You can see first the video that the robot arm, robot body is coming first, but anyway, printing on the side to fully integrate the conductive interface. It's an easy piece. We don't need to touch any sample rotation and etc. to build this. And second video shows you the curvature trace building by this Fanuc robot holding the printer head, and we can make curved 3D printing stops by using this. Okay, so this multi-directional fabrication is well known, like welding and CNC, whatever, but the 3D printing, we need to have thinking about multi-directional slicing, so and tool path generation, etc. So it is still kind of developing stage, but many researchers are working on this. So that's the first item in the manufacturing side, and I want to move on to biomedical side. So human-robot interaction can reduce actual interaction between the patient and the healthcare steps. That was our own idea. So humanoid robot or whatever robot interface can interact with the human body, and then we can detect and then collect the biomedical signals, biosensing signals. So this is one of the example of electrocardiogram sensor is attached to robot hand. The robot hand is interacting with the human body and then collecting continuously, repeatedly, whenever we want, this electrocardiogram or the blood pressure measurement. So this is the second research highlight I want to introduce you. So we are working with many different types of biomedical sensors attaching to humanoid robot hand, and then it can interact with the human. Then we can reduce the interaction between the clinicians and the patients once again. So that's a second highlight. Moving on, we talked about human subject. What about the plant? So the third one is about the plant health robot sensing. So eventually, robot arm with a kind of mobile platform, it can move around inside a greenhouse and then checking plant health. Actually, whether the plant needs more water or more nutrient, or it is excessive water by irrigation system, then it can reduce the irrigation amount, something like that. So this robot, when you see this video, robot is checking leaves electrical potential to see the water stress. And when it is detected with the electropotential signal, you can see this diagram that we transform it to the two-dimensional image to, this is the database for our machine learning, right, training. And then once it is trained, the decision making, whether, right, from the library, whether this is randomness, the sense, the signal demonstrate the plant needs more water or not, then we can do autonomously resource managing is possible. So this is a drip irrigation inside of the tomato greenhouse. So once it is like you see, oops, maybe the video is not working, unfortunately. But it is actually the irrigate started, and then when we detect the water is overflowed a bit, then it autonomously reduces its water irrigation amount. That's the video itself. So I can move on. So another robot use case for the agri-tech is we call the autonomous weed managing robot. So nowadays people think about weeds, right? Chemical resistance a lot. So weeds can become resistant to any types of control nowadays. So one of the example we would like to develop is making autonomous laser killing weed, right? So like this video, when the machine learning identify weed and then classify weed, which weed it is, then the laser can, right, shine, and then in about 10 seconds, less than 10 seconds, that there's a small weed that can be killed. That is one demonstration we made, and the weed managing robot is on the way. So this is first prototype. We want to move on to track-based weed managing robot to make a better fit to the large size farms. And also it is equipped with machine learning again. So majority of the robot application in my research is combination of machine learning and the robotic application together with a sensor. So sensor giving the signal, and an AI machine learning trained, and then it can make a decision and then actuate robot to do next thing. All right, so another application we are working on is apple. As you know, British Columbia, we have a lot of orchards. So this is just a mock sample demonstration, but we have a 3D printed like a human hand, but it is really good picking robot application. So again, computer vision and this machine learning decide this apple is right, mature to pick up, then this 3D printed hand can pick, and then we can harvest that. So it is moving on to next stage to make a mobile stage and then going into the orchard now. Last but not the least, the user case of the robot, we would like to talk about the drone, actually. So drone has been one of the really good vehicle for sensor, but our idea is equipping with nitrogen, phosphorus, potassium sensor, actually. So this MPK sensor autonomously moving around, checking different location of soil, and then getting, this is a flying demo of the this drone, and getting this kind of MPK contour map. Then this information can be given to farmer, and the farmer can recognize which part they need more nitrogen or phosphorus, this kind of distribution. So these are ongoing project we have. Okay, so I think I would like to wrap up. So my research and SFU mechatronics education was introduced. So the manufacturing side, biomedical side, and agri-tech side. So if you have any comment or the question, feel free to touch base with me or to visit our exhibition stand. Thank you so much.
Thank you so much, Wusu. Great presentation. Thanks for coming all the way from Vancouver, British Columbia, Canada. Good to see you. So we will be back at 10:30, Sarcomere Dynamics. Okay, thank you, everyone. Your time, whatever you want to do, because it is, I don't think there's anyone after you. So if you want to take an hour and a half. It's not happening.
Was there a talk before me? They didn't show up
There were two talks. The first two happened. The 11. They do extended and VR kind of stuff. He was actually on a podcast recently, and we're going to pull the chairs up and do a fireside. This is with Nordspace and Mari, who won the award, won the robotics award. So that's going to be a good one. That 3 o'clock, that's what I thought I was getting myself into, but apparently. But I guess I get to eat lunch today, so that's nice.
Oh my gosh. Okay.
Cool. Title?
I'm the CEO.
CEO. Great.
Yeah.
Sounds good. So, welcome back, Hall 7. Next up, we have Alyssa Ross, CEO of Metafold 3D, based in Toronto, and via Hall 17. Alyssa, take it away.
Thank you so much. It's my pleasure to be here. Okay, today I want to talk about lightweighting for aerospace. And maybe I'll first say that, as already mentioned, I'm the CEO of Metafold. I'm also a mathematician, and I love geometry. Geometry is absolutely everywhere around us, and manufacturers are increasingly dealing with more and more geometry. My job at Metafold is to help manufacturers make sense of their geometry, including for applications in aerospace. So I want to start with a kind of background on the idea of lightweighting in aerospace. And this is an older study, but one that I really like, which looks at the impact of the use of additive manufacturing for the aerospace industry. And you can see here, there's a few different scenarios. Well, it's a little hard to see there, but a few different scenarios that include the adoption of additive manufacturing and the degree of global cooperation. So global cooperation is something I can't control, but I like to think that I can have an impact on the adoption of additive manufacturing by making it easier for people to use additive manufacturing. On the right-hand side, you can see that there's a few different scenarios on the energy consumption based on the adoption of additive and the global cooperation. And on the far right, in that BH scenario, this is with high adoption of additive manufacturing. What this really means is manufacturers taking advantage of additive manufacturing to remove material from their parts, to lightweight their aerospace parts. And what I really like about this, it's a bit hard to see, but what I really like is that sort of medium gray section right here. This indicates the energy savings that result throughout the use of that part. So the lifetime of use of the part. And you see that the energy impact of removing material is greatest from the use of the part. So it's not in the manufacturing methodology, it's in the lifetime of use of the part. And this is where geometry plays a huge role. The shape of the part determines its mass, which determines the energy use required to move it. The second point in favor of geometric lightweighting is that we've really reached a frontier of material innovation for lightweighting. So aerospace producers have really pushed the boundaries of material innovation to find the lightest materials. What we're seeing now is that we're at a frontier of the ability of chemistry and metallurgy to come up with new materials, which means we turn to geometry. And shape has a huge impact on how much something weighs. And we can remove material from a part in very sensitive ways that don't compromise strength, but lead to reduced energy use. So my position is that new advancements in lightweighting will come primarily from better use of geometry across all manufacturing methods, so not just additive manufacturing. There are, of course, some challenges of geometric lightweighting with trade-offs. So how are you producing your parts? Are you using traditional manufacturing? Are you using additive manufacturing? These have very different profiles in terms of what you are able to do geometrically. There's also complexity, and this is related to the first point, that the more complex a shape is, it might be harder to produce. So you might need to really consider a balance between a more complex part that is lighter versus making it more mass producible. And where we come into talking about Metafold and our strengths is that explorations of shape as they relate to performance are not very well supported by existing approaches in CAD, in design software. There's often a very significant lag time between the design of a part and its simulation. And finally, if you're familiar with the concept of topology optimization, this is also a kind of limited approach because it tends to optimize toward one solution, which may be locally but not globally optimal. The bigger question here is this. Very simply put, how do we find a shape that satisfies all of these constraints? If you hand me performance targets, manufacturing constraints, and some kind of physics that you care about, what is the answer to that optimization in shape? Metafold created our technology called geometric intelligence to answer precisely this question. So I want to give a little bit of kind of market context as well. The amount of 3D data in the world is exploding. Just like all data, we are producing more and more and more of it. And my argument is that the 3D data that is embedded in engineering or CAD software or CAD models is very valuable because it has such a direct impact on production and safety. Now, what are manufacturers doing with all this data? So they need to make critical decisions from 3D data every day. And incorrect assessments can be very costly. So what are some examples of these critical decisions? So a contract manufacturer might ask, how much should this part cost to make? Or even, what manufacturing methodology should I use to produce this part? In aerospace, and this is what I'm really focused on today, how much material can I remove from this part? Obviously without compromising its strength. And maybe a bigger question is, are there other parts in my whole catalog of parts that I produce as an aerospace manufacturer that are good candidates for lightweighting? We also do a lot of work in sportswear, and here the sportswear manufacturers are really pushing boundaries of innovation to propel athletes forward, for example, through their innovations in running shoes. And so here, a sportswear manufacturer might really care about the best shape that will return energy to the athlete. So Metafold supports very knowledge-rich manufacturing, very data-driven manufacturing, and geometric intelligence is a toolkit for making some of these critical decisions from 3D data. Specifically, we help manufacturers analyze existing parts for cost and for manufacturability, to design incredible and outperforming new parts, and to develop scalable and proprietary CAD tooling that exactly fits their process. So we do a number of different things, as I just mentioned. The one I'll focus on today is design optimization. So here is this, trying to answer that question that I posed earlier, how do I balance performance, cost, and manufacturability? But I'll say we also do some of these other things like rapid manufacturability analysis, accelerated product development, and identification of similar parts across a part catalog. Okay, so looking at a couple of case studies. So we are working with Safran, the French aerospace manufacturer, on a lightweighting study. And they are, by the way, this is not their part, and I unfortunately can't share their part, but this is not it. It's just an example of a lightweight part. But so they're really interested in different approaches to lightweighting, very controlled approaches. And they were finding that they were using an existing topology optimization, and they were finding that this was giving them an answer that was light and it was strong, but it was also required downstream changes in the way they installed that part. And this was a really big problem because it would kind of have these knock-on effects throughout their production. So they were really looking to quickly iterate between design of new parts and simulation of the performance of those parts so they could get to an exploration of the design space. They also have very aggressive sustainability targets, like many aerospace manufacturers. So Metafold is helping them with a design of experiment capability to help them identify very high-performing lightweight candidates for their aircraft. And they're targeting a 50% weight reduction. So they're starting with a single part, and I'll come back to that point. So we, in the introductory phase of this project, we began by comparing different fill strategies for their part, which is a pin. And all of these different structures had the same mass. However, they all have different strengths, as you can see in this force displacement diagram. So we were able to very quickly create these geometries and simulate them all at once. So you get the results all at once. And this means that you can very, very rapidly explore different shapes and how they perform. And we're able to do this across a variety of different geometric form factors and variations. So the idea here is that by using this design of experiment, by systematically varying the geometry, we're able to also systematically analyze the results. So it's not so much that this answers the question of what part is best. It gives you a range of things to consider and allows you to apply your engineering expertise to the problem. So this is the kind of pulling it all together into one format. Let me just, which is a dashboard for lightweighting. And here, this was 27 studies done in 5 minutes. We can actually scale this up to thousands of studies done concurrently, so that you can really explode your design space and consider a huge range of possibilities that allow you to find very, very performant results. The next phase in that project, in the lightweighting project, is to move beyond a single part and look at a catalog of parts. And this is where the strength of the Geometric Intelligence Toolkit really comes in the sense that we can perform an automated query across thousands of parts to look for other candidates that are suitable for lightweighting. So you might be looking for regions in parts that have a lot of material bulk, where you would imagine there would be a candidate for material removal. And also for redesign. We can also just identify similar parts in their part catalog, which is a surprisingly challenging geometric problem. So I want to do a second case study here, which is not in lightweighting. It's on heat exchange, but it indicates in a little bit more detail our approach and some of the potential results. So this is for a dashboard, a decision-making dashboard that would compare conventional versus additively manufactured heat exchangers. So our customer was very interested in this. They were producing very performant additively manufactured heat exchangers, but as you probably know, when you produce something with additive manufacturing, it can be very expensive. So they wanted a framework for decisions about when they should use additive versus when they should just use an off-the-shelf heat exchanger. And we proposed to them a dashboard for comparing these two things, which are otherwise very difficult to compare. So I want to share the results of a study we did on shape to compare different structures for their heat exchange properties. So this study was asking this question: what structures have the highest surface area with the lowest pressure drop? And this is relevant to heat exchange. The more surface you have to exchange heat over, the more heat can be exchanged, but you do not want to slow anything down. So you want to minimize pressure drop as your fluid or your air is flowing. You want to minimize the pressure drop. So this is a very actively studied problem. So our approach to this was to generate a very large data set using our SDK, and then simulate the heat exchange on that data set, and then kind of zoom in on an area of high interest. So there's 3 steps here. Okay, so in the first couple steps, we created a large data set of structures, and in this, we were able to use our implicit geometry kernel to create very high complexity structures, and it was very easy to create this as well. So you can see we have some regular structures, and we also have some more organic spinodoid structures. So hold on. Right, so the results of this, we ran a fluid flow simulation on this to look at heat exchange, and the results are in this chart of surface area versus permeability. So we are really interested in structures that have higher surface area and higher permeability. So we want to minimize pressure drop. And you can see that there's some maybe familiar structures on here. The gyroid is often considered one of the best structures for this. But in fact, some of the more organic and unusual structures, like the spinodoids, perform better. They are at once higher surface area and also higher permeability. So this was the first surprise of the study. And what we did following this is we took some of the highest performing structures and we did a further design of experiment. So we took 27 new structures that were blends of these high-performing structures, and we conducted, again, this fluid flow simulation. And so in this green area, this is the previous graph area, and you can see the results of that new study, which kind of explode that design space again. So it shows you the power, in my opinion, of looking at a broad sweep of data prior to zooming in on an area of interest. So I'm just going to go back to this for a second, conclude this section. So this represents how we would approach a problem involving shape and its performance. So in this case, this is on structures for heat exchange. We are doing the same approach for structures for lightweighting, for aerospace. And we can really take any problem coming up for any kind of performance target and use this approach. So I want to just say a few more comments about the rest of the Metafold capabilities, and then I will conclude. We work a lot in high-mix, high-volume manufacturing, and this is for contract manufacturers who deal with a large volume of different designs, different CAD parts. So for them, they really care about, they receive a part, they want to know what manufacturing method should I use to make this part? Is it likely to succeed, or are there any areas that might pose a problem? And importantly, how much should it cost? Now, this is actually quite a challenging, very challenging problem to solve, but Metafold's capability and our geometric intelligence toolkit is able to detect features, and our customers can use those features to build models. So what's interesting about this and what I really like about this is that using 3D data, it is very difficult to train a machine learning model. No one manufacturer has enough 3D data to train a meaningful model, and it's a very rich space. 3D data is a very rich and heterogeneous space, which means it's very difficult to extract a signal from that data. Our approach, we're able to convert 3D data into powerful shape descriptors. These are kind of metrics and qualities of the 3D data that can then be used meaningfully to train a learning model, even with a small data set. And this is maybe one of the things I'm most excited about for Metafold. Okay, so wrapping up here, Metafold, our approach is to give our customers a very knowledge-rich approach to manufacturing it, very data-driven approach. Our API is used by manufacturers to analyze geometry, whether they're designing a new part or assessing an incoming part for manufacturability. And so we can look at these two approaches here. Traditional manufacturing, there's a limited flow between design, prototyping, and production. And it tends to be very slow with a lot of lag as a design moves to prototyping or simulation and gets thrown back to design to be reworked. There's file format conversions, and it's very laggy with very little information flow. And our approach is to try to do much more digitally by giving our customers a very knowledge-rich approach to 3D geometry to help them make better decisions, to have more information about the 3D geometry that they're working with. And we believe this results in a higher success rate in the manufacturing, better parts being produced in a better way, and ultimately a reduction in waste as well. So thank you so much. Maybe summarizing that our approach is to use geometric intelligence to analyze existing parts for manufacturability, to design incredible new parts, and to develop scalable CAD tooling. So thank you so much, and I welcome any questions if there are some.
Great. Thank you, Alyssa. If there's any questions, we have a few minutes. Hall 17?
Yes, we're in Hall 17. So please come visit us under the Canada flags and welcome your visit to the booth.
Or Toronto, Ontario.
Or
Just
visit
make
in
the trip.
Toronto. Yes.
Okay. Thank you, Alyssa, very much. Welcome back to Hall 7, everyone. We've got a great afternoon scheduled, and we're kicking it off with my good friend, Michael Rosas of Virtualware, his colleague, and my new friend, Mikhail Ayani, Simumatic, but it's kind of the same company. And I've got a couple nice connections with Virtualware, with Simumatic, with Michael and Mikhail, because one, Virtualware's Canadian facilities are located about a 10-minute drive from my house in Hamilton, Ontario, and in the building of a former refrigerator and stove factory where I used to work when I was 19 years old. So that's super cool. I've also immersed myself in Virtualware's technology, and I mean, long story short, it's pretty rad, and we're going to hear more about it today. Michael, Mikhail,
Excellent.
welcome.
Thank you.
Thanks for being here. Michael, why don't you kick us off? Tell us a bit about yourself. Tell us a bit about Virtualware.
Okay. So, well, thank you very much for the introduction, Brendan. And actually, one thing to add, our location is right across from the head office of NGen as well, too. So we share that space together. So Michael Rosas, I'm VP General Manager at Virtualware. And essentially what we do is we help companies adopt and scale XR technology. We work across a lot of different industries, but particularly one of the industries that we're really focused on is manufacturing. Because there's a lot of potential in regards to our technologies and that ability to be able to scale it within the manufacturing industry and really bring value. And so one of the things that has happened recently, and it's one of the reasons why I wanted Mikhail to come and join us, is we were talking with a lot of people within the manufacturing industry, and what they wanted was not just the ability to simulate, let's just say, their manufacturing facilities within a 3D environment, but they wanted something, let's say, more within the realm of virtual commissioning, of things that they could utilize across their value chain, not just within that final sort of deployment of XR technology. And so this was something that when we met Mikhail, who developed Simumatic, we saw a synergy there that was helpful in us being able to create a vertically integrated solution for the manufacturing industry, being able to provide the ability to manufacturers to create their own digital twins of their automation systems, but then also being able to connect it and visualize these in virtual reality, let's just say displays or different kind of scenarios, which is sort of at our core of what we do. And so that ended up working out really well, in the sense that even we ended up acquiring the company. And so now Mikhail's a part of the Virtualware team, and that's one of the reasons why we're here, because we are essentially bringing this to especially the Canadian market, where there's a lot of interest in finding ways to be able to optimize what they're doing and utilizing digital twins to be able to be more resilient, compete on a global level, and work with local partners, local integrators, people who are all essentially working together for a similar cause and leveraging each other's expertise and technology. So.
Great. And Mikhail, coming to us from just north of here, from Sweden.
Yeah, Sweden.
And your background is with the Simumatic application. Could you tell us a bit more about yourself, about Simumatic, and about how you got tangled up with Virtualware and my friend Michael here?
Yeah. So I'm originally from Spain, but I've been living in Sweden 15 years. Since maybe 20, 25 years back, I've been playing with digital twins and virtual commissioning, and started the company 5-6 years ago, Simumatic, which was acquired, as Michael said, last September, October. And my background is in automation engineering. So everything around Simumatic is my experience as automation engineering, the problems with real commissionings, how to solve those problems, how to make engineering easier and more efficient, and that's where virtual commissioning comes to place, and the digital twins and emulation technology. So.
Okay.
Yeah.
So tell me which term you prefer that I use.
Okay.
Extended reality, virtual reality, augmented reality. I imagine there are nuances.
Yeah.
How would you best characterize your technology?
Yeah, so we're going with extended reality technology because it's a catch-all, essentially. Obviously, there's going to be some shifts within the market in regards to sort of where people gravitate towards. But ultimately, we're a platform that allows for that ability to be able to deploy in these different types of displays or headsets. And that even includes even like a regular 2D displays as well too. So, ultimately, we are a XR company, a platform that helps companies adopt and scale this technology across their value chain, essentially. So an engineer could be using it for a different purpose than someone in training, right? And so, again, the same thing. They could be using tools like Simulmatic to be doing certain emulations of things, checking out and let's just say mixed reality headset so they could see it within a shop floor, right? So they could see a digital twin version sort of basically projected in front of them with the real world. But let's just say that same production line, once it goes into production, you could use that digital twin to create training scenarios where maybe actually you do want to be in a virtual, fully immersed virtual environment because you're not on the shop floor. You could be anywhere in the world, but you could be in a digital virtual version of it. In that particular case, it could be virtual reality. So we have that ability to be able to interconnect and take away that friction from companies having to figure out, hey, which one am I doing or anything like that. No, you can just get into that content, connect, and make it easier for the actual end user to be able to use it as an innovation tool within their company. So that's really the big thing that we're really trying to do here, because oftentimes, where things end up having bottlenecks, which we all understand in the manufacturing industry, is that you want to optimize. And part of it too is optimizing your information systems, your software for your workers to be able to actually utilize it. And everybody's going to have potential different use cases. And so what we saw is we need a platform to be able to make it easier so that every single type of profile can participate with these technologies to move it forward and for them to benefit from it.
Very cool. Mikkel, tell us, spare no detail, tell us about virtual commissioning and how VirtualWare and Simulmatic help enable that.
Yes, to understand virtual commissioning, you need to understand the commissioning, the real commissioning. So real commissioning is when system integrator or machine builder, they're going to build something, an automated system, and they put it in the customer's facility. And the commissioning process is when they put together the software and the hardware and make it run and test, validate that the customer specifications are covered, okay? The problem with the real commissioning is that you cannot do it until you have built the system. And this usually is delayed. You have here very big companies having issues starting the production lines because of all the complexity we are adding to the automation work. So virtual commissioning is giving tools to all these engineers, all these staff working in these projects to work in earlier phases, validating and testing their solution. So instead of waiting until everything is built, they use a digital twin so they can test their solution. That's the thing. What does it make? It makes everything work way more efficient. We usually call it like an insurance because you can test everything way earlier. So when it's going to be tested in reality, the main issues are already detected and fixed. So the real commissioning is reduced by a lot. And that's key because real commissioning is abroad. It costs more money to have people working at the customer facilities. So basically that is the virtual commissioning and why it's so important nowadays.
Yeah, essentially, I mean, on a high level, it's risk mitigation, right? It's that ability to be able to.
That's the thing.
Yeah, and that's where the value is. That's where companies are starting to say, hey, this is how we even want to standardize and do this moving forward because we're just minimizing the risk of a problem happening on site, which is extremely expensive to take care of. And so this is why we're seeing it. And now what was interesting with Mika was doing is that his clients were saying, well, we want to visualize it in virtual reality. And then ours were saying, we want to be able to do the digital twin. And so then that's where that symbiotic aspect came through, where it's like, okay, instead of us building what he does or him building what we did, and that's why we joined together and provided a vertically integrated solution for the industry.
So you have team members working in Hamilton, Ontario, Canada?
Yep.
In Sweden?
Yep.
In Spain?
Yeah.
I mean, tell us a bit about that process and how that comes together. And does your own technology enable some of that collaboration?
Absolutely. So of course, yes, we have to be our own adopters of our own technologies in many ways. And so it allows us, especially because you've been able to witness the room at McMaster Innovation Park, you know that ability to, obviously for local teams to be able to work together in these simulated environments on a one-to-one scale, kind of like similar to, and maybe we can get into it a little bit later, but what we're doing with the Nexstar battery plant and that whole idea of the people training kind of like in a real, sort of a real feeling environment. But we have the ability to connect with different rooms as well too. So essentially with the team in Spain, there could be a certain project or something that we're working on, and we could go in there and review what's happening live with our team there, collaborating, as opposed to it being on a Teams call, which really doesn't, you're just talking about it. We can actually hop into it and experience it and say, hey, this is actually potentially not working properly in regards to maybe an interaction, all these kinds of things like that. So the technology is not just an end sort of application, it's an innovation tool that can be used throughout the iterative process of the life cycle of whatever it is that you're doing. And exactly, we use it internally, and then we encourage people to start to and build that awareness for them to see that they can do it as well too.
For those of you who are not aware, Nexstar Energy is Canada's first electric vehicle battery plant. What can you tell us about your collaboration down in Windsor?
Okay, so this is led by Invest Windsor Essex, which is the economic development office based out of Canada's automotive capital. They've been really, I would say, very forward-thinking in regards to how they've been able to attract these kinds of investments to their region, and then also understanding that need to be able to upskill workers to be able to work in these facilities that haven't existed before in Canada. It's technology that's coming from South Korea, essentially. And so there was a unique scenario there where there's the ability to, along with work with Upskill Canada and Pallet Skills, to be able to create a program to be able to train the factory workers that will eventually be working, let's just say, in the factory before it's even built. So the idea here is the creation of the digital twins of the factory environment and being able to bring in the people so that they could go through the whole process of understanding how to work within the factory without actually setting foot in it. Now, what is the advantage there? There's the ability to obviously validate whether the people can actually get to the skill level, what's necessary to actually be working there. The people who maybe don't, maybe there's a way to be able to find another role that could be more suitable now that you have an understanding. There, basically a way to be able to start to place people in the right positions. And then by the time that the factory opens, you don't have this whole sort of time where you have to onboard a bunch of people all at once. We're talking in the hundreds of people. And so you're basically cutting down your time. You get into production much faster. And this is really helpful. It's crucial on an ecosystem level to be able to start to think of things this way. If Canada is attracting this type of investments, right, these large investments that are happening, we also have to have some kind of plan in place for the workforce and how we're going to develop them for the particular things that are happening. So virtual reality technology, utilizing it within these types of the rooms that you're talking about, is something that can help, right? It's not going to solve everything, but that it can help get us there much quicker and faster, and then even be something that can continue on throughout the actual life cycle of the operations, where as you also have churn, and you have different things, you could be training people in safe virtual environments before they actually ever get on the factory floor. So,
Great. So for those who drive in the future a 2026 Dodge Charger Daytona EV,
yeah.
that's going to have a battery made at Nexstar by people trained using
Yeah.
virtual wares
Yeah.
technology.
Yeah.
Changing gears.
Okay.
Mikhail, we're day 3 of 4 of Hannover Messe. How has your experience been? What have you learned? What have you seen?
So in one side, you can see that technology is advancing, but in industry, it's not going that fast. So virtual reality, AI, and so on, it's been some years around. We are seeing that more than evolving, they are kind of merging. So things like we are talking here, digital twins, VR, probably in a few years we will see AI included in these technologies and so on. So I think we are going to see, we are starting to see that different technologies are merging together and providing more value to the end customers. And I think this is going to be the key with Simumatic Viru together. Now we can take from Industry 4.0 to Industry 5.0, we can take the human in the machine. These applications where we have human-robot collaboration, now we can actually reproduce them in the virtual environment. We can have operators working together in a virtual environment with robots. Maybe this kind of new applications where operators are a bit afraid of this new technology, they can be trained in virtual environments. Even more when you introduce AI and you don't know exactly how this AI is gonna work in an environment. Digital twins will offer the environment, safe environment to test these technologies and so on. So I think we will see these kind of mixes in the future years here in Hannover. Yeah.
Great. Michael, same question.
Okay. So yeah, I think to add to a little bit about what Mikhail's saying, the key of what we're seeing here is that there's the Industry 5.0 human in the loop. So we all know AI is coming. I mean, it's been the talk of this whole event. And so what I like to say is we need to ask ourselves the question, okay, as the humans, as the ones who are in control, how do we interact with an ever-changing world that is becoming more digitized, right? And in particular, obviously, we're talking about the manufacturing industry, but we know that this is happening on a global scale, on a macro level. And so that's what I find is really interesting, because we're already finding use cases where we can start to have that human interaction within the digital space and bring that essentially humanity to things where previously it was just on a screen, it was more abstract, I guess, in some ways, where now we're going to be able to be living in it, right? And so I think that we're just scratching the surface right now. We're doing sort of like low-hanging fruit, like training and all this stuff like that. As this becomes more adopted, there's going to be, the new generation is going to come up with even more efficient ways of how to utilize this to be able to have a global network of ways of being able to communicate with one another and with digital tools, agents, all kinds of stuff like that, but from a human-centric level where we're not taking away that core of who we are and giving it up to some zeros and ones kind of thing. So I think there's a lot of promise. And then what I like about, obviously, in regards to the manufacturing industry is that because it's so engineering driven, is that people are always open to something that potentially can help in regards to optimize what we're doing. And so it's a great space to be having these conversations, because this is where people see and say, hey, yeah, this is something that we can potentially do. And I'm sure we're going to see much more of in the future.
What's next what's post Hannover? What happens for Virtual Wear Simumatic, and what are you most excited about?
So there's a few things that we'll be announcing soon that unfortunately are we can't be talking about right now. Yeah, but at least there's some things coming down the pipeline, especially in Canada. I think with everything that's happening, there's an interesting sort of a focus, especially on us becoming more resilient and helping one another, and kind of like all of us sort of like helping be a part, like partners together to work. So these types of announcements that are going to be coming out, I think, are encouraging because it shows that ability for partners to work together, to be doing things potentially even on a global scale that are first, and that can utilize this technology in meaningful ways to help everything from local economies to on a Canada-wide scale. And what I find really interesting is also even that ability to even start to establish that at a first, where we could even start thinking about all the stuff that we're doing in the digital space and as exporters. Because if we start to figure it out with what we're doing and what we're building, because there's just so many interesting projects that are happening in Canada right now, and we start to leverage that, other people are going to say, hey, how did they do it? How did they go through this? And obviously some tough times, and what did they do to do that? And we can export the stuff that we're doing just because it's digital. It doesn't have to be an actual physical product. I know we're here in manufacturing, but there's going to be, that's what we're trying to say. There's value in the digital as well too, and that know-how. And Canada could be one of the ones, and that's why I'm really excited, because that's why we're here and we're talking to everybody, because we think that together we could do it. So. Amazing.
Well said. Mikhail, any last words?
I think I can say from more a technical perspective, I think related to Industry 5.0, I think we can start thinking about ergonomics. Again, thinking about the human in the center and so on. I think this is going to be something happening and more requested from our actual customers and so on, because we have the tools now to make even better industry for us, for the people working. Yeah.
Great. And final question. It's a tough one. Favorite NGen team member? Mine's Christy.
Oh my God, they're all, I mean, so far this whole this whole event has been amazing. I'm going to have to go now and introduce myself to Christy, because I need to see obviously why you guys have such a great relationship. The NGen people have been absolutely amazing, and even in regards to like inviting us to be a part of this. And these are the kinds of things that there's conversations that are happening, and I'm excited to be able to work, again, collectively with everybody who's also in regards to part of the NGen team to find solutions to leverage this for us to make the most out of all of this. So I'm gonna say everybody.
Yeah, true.
Very Canadian of me, isn't it?
And if people want to learn more about Virtual Wear and Simumatic, how do they find you?
Well, we have the QR code there. You could connect with me on LinkedIn if you'd like to, and I could share more. But you could also check us out at virtualwearco.com. We also have a lot of videos there. We have the stuff also from like a microsite of Simumatic as well there too. But obviously the best thing is to just reach out to me, and I can give you a more personal approach of explanation or a walkthrough of what it is that we do.
Or come to the party tonight.
Yeah. Yes.
See you later.
Okay.
Mikhail, thank you very much.
Thank you, Brendan.
Thank you.
Really appreciate it.
All right.
Thank you.
And we will be back at 1:30, which is probably coming up on us pretty soon. So thank you, everyone.
is hot now.
Thank you, thank you. This is your 5-minute warning. Hall 7, 3 o'clock. York Region. Robots, space, and the power of partnership, starting in 5 minutes with Mari, Nordspace, and NGen.
I just saw Harold what? I need my glasses.
Welcome, everybody. The moment you've all been waiting for in Hall 7, York Region's robots, space, and the power of partnerships. We've got Yi Li, Maple Advanced Robotics, Derek Chow, Nordspace, and Rob Mastrato of NGen. Before we get going, we have some special opening remarks from Mayor West of Richmond Hill. Mayor, take it away.
Well, thank you very much, Brendan, and thank you, everybody, for being here. It's a real pleasure to be at this conference, and particularly in with this group of people that we're about to hear from today. I just wanted to start us off a little bit by talking a little bit about York Region and introducing that for anybody that doesn't know us. As the mayor of Richmond Hill, it's really my pleasure to be here. I do want to introduce a little bit about York Region. We are north of the city of Toronto, Canada. It's a large region. We have over 1 million people in 9 municipalities across the region. We are also the fastest growing region, one of the faster growing regions in Canada, growing faster than the provincial and national averages. We are projected to increase to 1.79 million by 2041, and 70% of that growth is expected to occur in the southern 3 municipalities, and one of those municipalities is my home of Richmond Hill. Our region is home to the largest technology hubs with close to 5,000 ICT companies with subsector strengths in AI, hardware, and enterprise software. With the 3rd largest manufacturing sector in Ontario and the 5th largest in Canada, York Region has the highest talent concentration in the Greater Toronto Area, with about 13.4% of the region's workforce is involved in natural and applied science occupations. So located in York Region, as I said, Richmond Hill is fortunate to be the home of Canada's most educated workforce, with 79% of working-aged residents holding a post-secondary education, and we have the highest number of STEM graduates per capita in Canada. Richmond Hill and York Region form a part of the highest technology workforce concentration in the Toronto-Waterloo corridor. This skilled workforce is one of the factors that attracts innovative companies to Richmond Hill and York Region. And a prime example of this actually is with us today is Mari. It's a Richmond Hill-based company and winner of the prestigious Robotics Award for 2025 at this year's Hannover Mess. So congratulations once again, Dr. Lee. Mari has chosen their business to be in Richmond Hill and part of Canada's largest technology cluster to capitalize on our highly educated and skilled professionals. So our ideal location in the Toronto area encourages networking and collaboration with other technology companies and support services. So on behalf of York Region and the City of Richmond Hill, thank you very much for attending today's session, and we look forward to hosting you at our next visit to Canada. I feel right now like I'm kind of like the opening band, and what you're about to see is the Rolling Stones.
Thank you, Mayor West. York Region, it's pretty great. I think that was one of the main messages. Hey, friends. We made it. We made it. We're here. So, Yi, why don't you start off, introduce yourself, and tell us a bit about Mari, about Maple Advanced Robotics. Tell us a bit about what you do, and, if you want to talk a bit about the award, feel free.
Okay.
Feel free.
Okay, thank you. Thank you, everyone. Yeah, my name is Yi Li. I'm the co-founder and the EVP of Maple Advanced Robotics. I also graduated from University of Toronto and the Robotics and Automation Laboratory, and many years ago. Yeah. But after my graduation and started working in Magna R&D Center and focused on the robotics and automation and to find the solutions to automate the manual stations with robots, especially on those hard to automate, uncertain environment, and so to find the solutions for. And as we know, like robots are not smart. And they are good repetitive to do repetitive work, but not very smart. And so that's how like we're capable find solutions with the AI and 3D vision in combination, and make the robot is more like a human, which can think and reason and also to do the action. So that is how we established the Maple Advanced Robotics to work into that direction, which is to make robot autonomous, and which means we are easy to in the robot programming and less requirement for the operator, but make a robot more adaptable to the environment. So in this case, we are very lucky and to be recognized by Hannover Messe and to get this robotic award at the first place. And that is a very good opportunity for us to demonstrate our robot station at this very important industrial event and in this very important industrial country. And it actually gave us quite a good opportunity to showcase our technology. Yeah, so thank you for this opportunity as well, and to discuss our journey and how we get there.
Amazing. Thank you, Yi. Derek, NordSpace is based in Markham, Ontario, with an emerging division in Newfoundland.
That's right.
Tell us a bit about yourself, tell us a bit about NordSpace, and tell us you're trying to be the first to do something.
Yeah, that's right. So my name is Derek Chow. I'm the Director of Operations at NordSpace, which is building Canada's first orbital launch vehicle. So as Brendan here mentioned, we do have our HQ for manufacturing design in Markham. And we also are looking to set up our first spaceport in the province of Newfoundland and Labrador, just outside the city of St. Lawrence, for those who are from Newfoundland. So NordSpace, the vision is looking to become Canada's next space and defense prime contractor, and we're looking to really build that end-to-end space systems solutions for anybody, outside the traditional space industry who wants to leverage, the values of having spacecraft or satellites up in space to help benefit their operations back on Earth. This could be anything from Earth observations to remote monitoring, environmental monitoring, high-speed communications to the farthest reaches of the Earth. That's the mission we're trying to solve. And so Canada's got a really rich history in space, and now we're looking to just complete the entire value delivery chain for our domestic economy and also for our closest allies.
Thank you, Derek. Robert Mastrato of NGen. Tell us a bit about yourself and about what you're doing at NGen.
Sure. Thanks, Brendan. My name's Rob Mastrato. I'm the VP of Projects at NGen. You may have seen us around. So here at NGen, we have this role of helping and kind of leading Canada's footprint in terms of hosting the Hannover Messe show. That's a very large part of what we're doing. But really, our mandate is all about developing this advanced manufacturing ecosystem in Canada. And so a lot of the companies that we have funded, they're here. It's great to see some of these companies like Mari, again, looking around, and it's exciting. I'm very proud as a Canadian to meet these great entrepreneurs, these great business leaders, and these great technical people across the country. And I feel very lucky that, not only here in York Region, which I'll speak about in a second, but the technology that's coming out from Canadian companies is world-class and is world-leading. And fantastic that it's getting recognized. Like we all know about the award that Mari received, but it is exciting, and certainly that's what NGen does. We provide funding and mentorship and coaching and so on, supporting the advanced manufacturing across the country. So here in York Region, I just wanted to say, in our first 5 years of our mandate, there's 165 projects that NGen funded. 12 of those projects, well, it's 7 or 8%, I guess, were actually projects that were executed in York Region. And excellent projects. I'd love to talk more about it, but that's what we do.
And Rob, before NGen, you have some experience in industry in Canada. Could you briefly tell us about some of that experience?
Sure. So my whole life, I was an operations leader for most of my life. It's been, I guess, over 30 years now, so I'm an old guy. The best part of my job is really sharing what I've learned, all the dumb things I've done in my life, and helping other companies and other leaders avoid some of those things. But yeah, the NGen is comprised of really ex-industry professionals, and the best part about it, as I said before, it is exciting to share, to coach, to really help companies be successful. So I feel like every day is you know, if you can come away and just know that, you know, you had a conversation, or we're able to make something happen, or a connection or a collaboration, if that just helps just even a little ounce, it makes me feel pretty good as a Canadian, as a father, as an industry professional. It's fun. It's a lot of fun.
Great. Yi and Derek, let's get really specific into some of the technologies you're developing and or some of the technologies with which you're engaging. Derek, why don't you start? Could you tell us a bit more about, again, some of the specific technological developments that you're working on, or some of the technologies that you're engaging with to bring those developments to the life?
Yeah, for sure. No, that's a great question, and we do get this a lot because we're a rocket company. They ask us, "Oh, well, rocket science must be hard," and we tell people that, you know, we're a very lean team, and we're actually trying to not break or invent new rocket science. And frankly, we're using technology that has been proven since the 70s with the Apollo missions, with the space shuttle. And where we are actually really focused on is the design and the manufacturing. So in the design phase, leveraging AI to help us with the mechanical models, with the CAD, with the simulations. So, you know, having great conversations here with some Canadian companies as well, and with you know, some German companies as well, large and small, on the amazing tools that they have, right, to help us with the mechanical design and the fluids and the combustion simulations. You know, speaking about NGen, we are leveraging a lot of additive manufacturing as well within our lab. Our engine is actually fully 3D printed out of metal, out of aerospace alloys. It's something that really hasn't been done until the last maybe 5 to 10 years, and we're bringing that technology into Canada, into York region as well. And that's something that, you know, is a core capability that we're looking to develop, and we're really focused on the cost and the performance of our technology. And ultimately, you know, rockets are going to be a bit of a commodity around the world. We're seeing a lot of different countries develop this sovereign capability. Of course, you know, given this now geopolitical background as well, it's very important that we think each country has their ability to get their own satellites and assets up into space. And so we're trying to make that as affordable and as assured access as possible. So yeah, so AI and additive manufacturing.
Amazing. Yi,
Yes.
tell us about, spare no details except for the secrets, about some of the Murray technology, what you're working with, and what its primary applications are.
Sure. Murray developed the autonomous adaptable robot system, which is the goal is to have a programming-free robot, especially for industrial robot, collaborative robot, and to make easy access to all the users. So it's not like a trained robot technician or like a robot programmer. So because that is kind of like the big obstacles in the adoption of a robot. So buying a robot is not that expensive compared to 10 years ago. But to operate a robot is much more expensive compared to 10 years ago because the engineering salary is going up crazy. And also to have a good experienced robot programmer is not that easy. You need years of training, experience, maybe smash some robot to get some experience on that. And so that is kind of like what we see the robot adoption is have the resistance is not just from the technology point of view, it's also from the owner. So the business owner, especially the smaller business owner, they're scared to invest in robot. And so that's kind of based on those, and we are developing the robot into, like the robot software to make the robot easier to use. Those means we are able to reduce this type of headache or like hesitant at the beginning. And so that is but the core is to use 3D vision and the physical informed AI as the tool to achieve that goal. It's basically what we did is we make robots see and think like human being, which means that when we see an object, we use 3D vision to, like our two eyes is actually 3D vision to locate the object. And then in our mind, we will generate the instruction and how to do this. And that is kind of in the robot world is the robot trajectory, which means with the robot trajectory, we are able to drive the robot to do the task. So that in that case, like what we achieved in like autonomous adaptive robot system is that we have those entire process automated through our software. So that is, we didn't like to say is like, we didn't ask the operator to write a code to let the robot to do that. Is the software is doing this job. Yeah. And for the application is that we start from automotive sector with the partner with the Magna International and NGen. And because the automotive leader have this vision and also the needs and to reduce the difficulty of robot programming. And they are the expert of to use robots all the time. And so that's how like, we work with the expert and to find applications in automotive sector, such as sanding application. Like we sand like car doors and B-pillars and car roofs. But then after the development, we're introducing the same technology into woodworking, which is a different sector which many of the owners never think about robot. This is a complete opposite. Like in automotive, you may see hundreds of robots in the plant, and in the woodworking shop, you see none. But as you can see, this kind of the transition, if the technology have a breakthrough, and we're able to transfer the new advanced technology in manufacturing from the advanced sector to the traditional sector, but without too much of the efforts. Yeah, so I think that is very important. We like to appreciate the help from NGen and advanced manufacturing sector, and so to have this development which benefit for all the manufacturing sectors. It's not just for one or two particular sector or companies.
And certainly in Canada, with the amount of emphasis we're starting to place on improving productivity in home building and in modular construction, it'd be great to see some of your robots with applications in those industries. Derek, you know, you're living in space these days. That's probably where you're spending most days. Yeah. What lessons, what applications, what type of technologies are you engaging with that, you know, in your day-to-day, they're being primarily applied to the space industry and specifically to rockets, but that might have broader applications, that might have applications in woodworking or in automotive or in another industry?
I mean, first of all, maybe you can give me a robot later for building rockets as well. Yeah, certainly the 3D printing, you know, like AI modeling, things, really anything that has a complex mechanical structure or maybe hydrodynamics, fluid dynamics, you know, those could be applied as well. So oftentimes it's a mix. We do try to get some off-the-shelf components. We also try to do some in-house if there is a very customized need. For example, let's say there are maybe PCBs that you could typically buy off the shelf, but maybe there's a form factor, or it's just too big, or for the volume to fit inside our rocket, or maybe to fit inside a microsatellite. Then we'll develop that in-house, and then obviously that has applications for others. We're seeing for like the microelectronics for the biotech side, there are some sort of technology transfers. For the additive manufacturing, we are seeing some going back into heavy industry, like mining industries as well. And of course, I guess sort of an easy one would be the defense side. Space and defense are often very close to each other, obviously. But nowadays, there are things being developed within commercial space industry that then will get applications back into the defense side as well. Whereas I think in the past it used to be the opposite. Things that are coming up in the future as well, we're looking to develop more sensor technology, especially with Earth imaging, or maybe like things like synthetic aperture radar, ways to more efficiently be able to perform Earth monitoring, like environmental, forestry, agriculture, etc. Those will require some specialized sensors as well. So there could be ways to obviously apply those to those sort of adjacent industries.
Great, thank you. So York Region is part of the broader Toronto metropolitan area, or the GTYA, as some of us call it. And what some of us know, what some of us don't know but should know, is that the Toronto metropolitan area is one of only two major metropolitan areas in North America with full-scale automotive and full-scale aircraft assembly. It's also the only one with full-scale automotive, full-scale aircraft assembly, and full-scale integrated steel making, plus space robots in Brampton at MDA, and biopharmaceutical products at Sanofi in Toronto. What types of supports, what types of partnerships in the broader ecosystem in York Region, in the Greater Toronto Area, in Southern Ontario, in Canada, what types of supports and partnerships within that ecosystem are behind your success, are behind your your growth trajectory, or are behind the success and the competitiveness of the broader manufacturing and technology ecosystem in the region? Who wants to go first?
I'll go first.
Oh, there we go.
I got the mic already. So, no, certainly that is without a doubt. It's very, very important to have the partnerships and the support from the members of our community, from the municipalities in the region, as well as from the academic side, and then also the SMBs and large companies as well. I think we've got the whole spectrum, right, in the what did you call it? The Greater York Region.
The Greater Toronto and York area.
Okay, got you. Okay. Yeah, and so part of my job is to go look for those partnerships as well, and that is sort of why I'm here as well, right, in Hannover. Building rockets and also other technologies, it's a hard task on its own, and we don't mean to do it just with one company. We do take the Team Canada approach. We do take an approach where we want to bring in the experts from every field to be able to contribute to this project. And so to give you some examples, we have a lot of academic partnerships with the University of Toronto on the microsatellite side, on propulsion using sustainable aviation fuels. We have partnerships with McMaster University on additive manufacturing. Waterloo also has a great manufacturing, advanced manufacturing there. We're looking at, and also beyond, right? All across Canada, there are other universities as well with really niche and really advanced areas of research that, I learn about day after day. On the small, medium business side, I'm learning great things like a company in Cambridge called Racer Machinery. That's like one of the only I think full-scale machining manufacturers left in North America. And so, when we're talking about doing things like new age of additive manufacturing, we have to go to them because they have the expertise on how to actually do this like automation with the 6-axis CNC and things like that, right? To integrate it with the new sort of additive manufacturing technologies. So definitely super important from the government perspective as well, having those supports to bring in members of the community together to network. I think it's, we're always very welcome and open to international collaborations as well. I just learned of great sort of programs that our National Research Council offers through the Eureka network and through Eurostars, working with companies in Germany and all over the EU. So that's something that I look forward to tapping into as well.
Amazing, thank you. Rob, your thoughts on supports and the broader ecosystem and partnerships?
Yeah, I mean, right off the top, if I think of NGen's approach, we fund collaborations. And so right off the bat, the type of projects that we get behind involve at least 2 companies, and one of those companies needs to be an SME, a small, medium-sized enterprise. So that in itself creates this collaboration. And the other thing we really want to see, and we're seeing more of, and this is exciting, is the level of input, level of creativity and energy coming out of academia. Some of the best projects that we have involve work coming from the academic institutions across our country. It's something to be very, very proud of. We have quite a great resource there. And the other thing I just wanted to add is when we talk about collaborations, and I know I was very guilty of this in my old days, when you're operating a business, you become very familiar with the other organizations around the block or within the vicinity you can drive to and so on. I think what we become very aware of is collaborations don't have to be in your corner, in your province. We have an amazing country and great tech that's happening across the whole country. And again, as I mentioned earlier, in our first 5 years, we funded 165 projects. Of those projects, more than a third of those were actually interprovincial collaborations. So a small tech company in Vancouver partnering with a couple of companies in Ontario. And the great thing there is that everybody wins. That's the kind of collaboration that will move us ahead. And the other piece that we're really excited about is, if I go back to the MARI project, which is a great reference for us, we had a small tech company working with a very large multinational, based in Canada, Magna organization. It's a great situation because they obviously were able to solve a key need for this multinational, but the multinational created the market pull, and it allowed them to kind of grow, and now you can kind of commercialize in a bigger way and so on. So, collaboration is so important, and it's great to see that it's happening. And when I look around, again, even seeing other Canadian companies here at the show who may not have known each other, that's the kind of stuff that will help us be successful and really push technology and technology adoption in a bigger way.
Thanks. Yi, what types of supports, what types of partnerships, what types of collaborations are behind MARI's award-winning success?
Thank you. Yeah, I would say location. This is we didn't think too much, and we decided to put our headquarters in Richmond Hill. It's to me, I think it's truly a technology center. And it's right in the center, which is not very far to downtown Toronto, not very far to Aurora, to Newmarket, not very far to Mississauga. So that's in that distance, like half-hour driving distance without traffic, though. And half-hour driving circle, we can cover like partners, end users, and suppliers. And there's never a shortage of the talent academias and the professors and students. And for example, MARI is welcome all summer students, and we receive many applications from universities and for summer interns and even new graduates. And that's how we came from there. Like when we graduated from a university, we're looking for to get the technology job, and that's what we can see. There's many opportunities for us to see, to hire like young engineers and new graduates, and this is the great location. So to attract the talent people into the area. And speaking of collaboration, and we have local government support from Richmond Hill City, York Region, and they are helping us on promotion about our name and what we do. Because as a startup company, we don't have any budget in marketing. We spend our market in product development, but with the help from like YorkLink and the city of Richmond Hill, they gave us those promotion opportunities in LinkedIn and through other channels, website. And so people know there is a company are working in autonomous robots right here. So it's not in US, it's not in Germany, it's right in Richmond Hill. And so that is very good for us to attract local customers. And on the other side it's very interesting. Like last year, we decided to find a new product orientation, and what else we will do out of automotive. Then this woodworking came up because our neighbor, which is just literally a neighbor, is only 100 meters away from us. They are customized kitchen cabinet manufacturer, right in the same, almost the same plaza as we are. And we are able to visit their place, their showroom, their factory, and we realize this is a real market. And there's a real customer needs on the customizations. And so we are able to use our technology into this type of industry. So as you can see, location. So it's not that we do not need to drive like 200 kilometers to find a customer. They're 100 meters away from us. So that is what I can see, this ecosystem, collaboration support, and it's not just from academia technology. It's everywhere. And so we're very lucky to have this kind of community and this ecosystem, which naturally grows, and with manufacturing, with the research, and we have small SMEs, and we have large, like a global manufacturing giant, and all in York region and in the driving distance, and so we can communicate and work with them easily. Yeah. Thank you.
Derek, what would you want everyone at Hanover to know about the workforce, about the talent pool that's in York region and in Southern Ontario?
Yeah, I think we certainly have a very diverse workforce, and it's one of the reasons why we also are situated ourselves in Markham, is to access that incredible talent pool. And we often say when we're pitching Nordspace, we say that there's a bit of a Avro-Aero moment as well in terms of the talent that is leaving Canada. And I think for us to be situated there and to create really great jobs there is important, as is for any companies from Germany or elsewhere who are thinking about expanding into Canada. I think your region has the diversity, has so many different disciplines, so many different universities and colleges and technical training institutes that will produce the skilled trades and the the level of skilled talent that you need to succeed. Lots of great business schools as well. So from the management and marketing, business development side of things, we're not just talking about technology here, but also, of course, building a real business that makes money. You've got a good talent pool there as well. What more can I say?
Rob, any thoughts on the talent pool in Southern Ontario?
Yeah, I mean, as I said, it's exciting because we do have the opportunity to work with the academia across the country. Here in Ontario specifically, I mean, there's incredible institutions. And then if I think about the talent pool, I mean, that's something we can always be bragging about here, being Canadian, being from Ontario. I don't know if everybody's had the chance to check out, even over my shoulder, the Robo Goalie. where you have some high school kids putting together a pretty impressive little situation with a robotic goalie. I mean, I certainly wasn't doing that kind of stuff in high school, so I'm impressed, and it's, again, as an older guy, I'm inspired by what I see, not just in high schools, obviously, but in the colleges and universities, and we're seeing that in the projects. As we build this advanced manufacturing ecosystem, there is absolutely a need for the kind of talent that's going to support this technology. And without it, I mean, without the kind of level of workforce development, without the level of academia that we have, it's going to become a problem. So I don't think I've spoken to a company really that hasn't said, we need this kind of person, or we could really benefit from this skill set. And so, again, there's a part of NGen. I'm looking at one of my colleagues out here, Peter, in the crowd, whose specific goal, and Peter's overseeing the mechatronics competition a couple booths over. So there's a lot of things, but again, it's inspiring. It has to start early. We have to kind of make sure that we're reaching our youth to kind of keep that pipeline going, if you will. But then once they're in the academia here in Ontario, it is outstanding, and I would say I put it up against any jurisdiction in the world.
Well said. Well said. So we are day 3 at Hannover. We've all had time to settle in a bit. Yi, what are some of your main takeaways? What are some of your impressions? What are you most excited about so far when it comes to Hannover Messe 2025?
Thank you. It's a great event, and you never disappointed from Hannover Messe. And there's many professionals and the decision makers are at the show floor and ask questions, and we exchange the opinions and also the ideas and to how to make it more productive. And also what I can see is Germany is the leading industry country, and also they see Canada is also a leading technology country and a manufacturing country as well. And we have the same level of technology, and we also have a great advantage in talent pool and also the leading technology, which we kind of like with the North America culture and influence, and which is kind of something new for Germany, and to when we exchange those ideas, and they feels like, yeah, you guys really strong in smart software and think about AI, how to use it in real practical applications. So that is very good experience in the past 3 days, and I will expect we'll have similar conversation in the next 2 days. And so it's a great opportunity to be here and to showcase our technology in this very great industrial platform.
Thanks, Yi. Derek, your impressions, your lessons, your takeaways from Hannover Messe so far?
Yeah. I mean, it's my first time here. It's certainly the day one was a little overwhelming, I think. I haven't even been to half the halls yet. So tomorrow I'm looking forward to getting out there as well. But to echo Yi's thoughts there, it's Germany here has such a deep expertise in hard technology and in industrial technology, and I'm just honestly blown away by the conversations that we're having. Shout out to the Canadian Trade Commissioner's Service as well for bringing us a lot of good contacts, bringing folks to our booth as well. Those conversations have been very fruitful, just sometimes to give us new ideas or even to do a little bit of knowledge sharing. I enjoy the sort of culture of wanting to make things happen, and just seeing like cool technology work, and so I'm looking forward to some of the following up on some of those conversations. A lesson I learned was you should buy flex tickets, because I've already had to sort of rejig my itinerary going home because I want to visit one of the research institutes here in Germany, and it's about like a 4-hour train ride away. So, yeah, but that's. Flex tickets,
That's a good one.
hot tip. Rob, I mean, we've been kind of tethered together in Hall 7, but in the moments that you've got to go out and explore, what are some of your impressions and lessons from Hanover?
I think there's two, and I'll start with just from the level of technology. I think, again, historically, I think people have always looked at, Germany and Europe as the bar, I guess, in terms of technology, and they're the ones that are at the top of the game in robotics and things like that, and automation. And again, very excellent product. What's been great, and as you said, you've been hanging around listening to these presentations and even spending some time and watching the Canadian technology companies interact. And what's great to see is, Canada has a great product too, and we can compete, and it's not that far off. And in many cases, we lead, and so that's exciting. So, and then the second part, maybe just as a Canadian, what I found really inspiring is, it's no secret. I'm not going to get into a political sideshow here, but it's no secret that Canada's under a lot of pressure right now politically. From our neighbors down south. So what was really great to hear, and it's been a common thread from the German and the European community, is that we do operate very much alike, and we do see opportunities to collaborate, and we do want to have trade agreements and work out and do business together. So that's been reassuring, and I'm very proud as a Canadian, and it's. There's lots of times I thought, wow, this is great. In a time of uncertainty, to have that kind of partnership kind of coming to the forefront from the German community, from the German business community, from the European community.
Great. Like many of us, 2025 has been marked by life leading up to Hanover, by Hanover, and I assume by life after Hanover. Derek, what are you most excited about in life after, in 2025 post Hanover and even into 2026?
You mean after getting some sleep? It's it's the going back to the research collaborations, R&D collaborations, of course, and finding ways to bolster our supply chain back at home. I think it's been echoed by many folks here that we've come all this way to Hanover just to meet lots of Canadian companies, and honestly, I've been amazed at what exists both in Canada and in Germany. So I would love to follow up on those relationships and really try to build something sustainable, right? And help us diversify away from some of our traditional trading partners. Really help to branch out, right? Yeah. That's what I have.
Yi, what about you? What are you most excited about post Hanover?
Yeah, there's a lot of follow-up work to do, and we have established good contacts and shared the ideas, and there's leads, and which opportunities for autonomous robots can be used in several sectors, which is like new energy and battery recycles, which is Germany company is focused on, and they have a long vision about this type of sectors, with new sectors. I think that's advanced robotics technology definitely is one of the very key elements which is in their mind. And we like to participate with them and into this journey. And who knows, maybe Canada will have this battery recycle business in the future, because we are the clean country and we create like a clean battery and in Ontario. So that is kind of what we can see, this opportunity to go abroad, to go to Germany, to see what they are looking for, what is in their mind, and so better shape up our vision and to the long run. I think there's many, after this show, there's many deep thinking and follow-up and collaboration and need to be addressed by us. Yeah, but this is a very exciting moment and for us to be here.
Great. Thank you. Rob, the last word. What are you most excited about post Hanover?
I think for me it's easy. The most exciting thing for me is what's ahead. I'm excited to see Derek and Nord Space and see what comes. I mean, they got a really cool trajectory, and not to be, no pun intended, but what's ahead for that company and what's going to happen for Canada is exciting. What's ahead for Mari, that's the greatest part, because we're all going to come away from the show and we have a stack full of cards. But for me, it's business and it's growth and it's development of incredible companies. I've had the pleasure of knowing Yi for years now and seeing how far Mari has come. And I'm looking over my shoulder at a company like Global EWS, a company that pivoted during COVID to do disinfection robots. And now they built in that technology, and they're doing bigger and better things too. So it's so great just to see that, in this point in time where we are, and 6 months from now, it's going to be wild, even more. The progress is that's the most exciting part for me. For sure.
Great. Rob, Derek, Yi, Mayor West, York Region, thank you very much. And we will be back on stage at 4 o'clock. And tomorrow at 3 o'clock, we have our second York Region panel. And I heard that tonight we have a party to go to. And we just made it through almost 50 minutes without saying the T word. So thank you very much, everybody, and we'll see you soon.
Can you hear me? There we go. Welcome to our talk. We're going to be talking about career pathways through mechatronics competitions. This is a panel discussion with a number of representatives from teams across Canada and Germany. Now, you've probably seen the mechatronics competition across the way, and this was an idea that we thought about last year when we were here at Hannover and thought, wouldn't it be great to have a bunch of students from Germany as well as Canada competing in a friendly competition and to demonstrate their capabilities in mechatronics. So next to me we have all the coaches and mentors for these teams. I'm Peter Warrow, I'm the Director of Workforce Development Programs, and I represent NGen, and these gentlemen are here representing all the teams. So I'll introduce them very briefly and then we'll start getting into the questions. So we have Josh Hamilton. Josh is from Conestoga College. Neil Mohammed from Humber Polytechnic. We have Daniel Barrett from Southern Alberta Institute of Technology, or SAIT. Michael Lin, who is from Festo, but he's representing the Team Germany. And we also have Greg James, who is representing Festo as well. So with that said, Josh, I'm going to start with you. So Josh, what are the benefits for students participating in mechatronics competitions, and especially in national or regional or international competitions? What are those benefits for students?
Yeah, for sure. Thanks again for having me here on the panel, Peter. The benefits are pretty widespread. When you look at the local college and the different inter-college competitions that we have, there's a lot of that camaraderie that gets built up there within the college, the training team and the training systems. And then when you move that out to the provincial levels, you see that same learning from different provinces, seeing how other people do things, the techniques, different things like that. And then you get that competitive edge, because we always at the college system have that drive to do better, that drive to be the best. And you kind of see that inside each of the provincial competitions. As you move into the national competitions, you start to see that variety of different ways different provinces train, how they view and approach mechatronics, where their strengths are, what you see differently. And then that just exponentially grows when you get to the international level. You'll see different countries and their approaches to mechatronics as a whole, as a competition, as a mindset. They're very different than what you might see at the local college level and even into the provincial and national level. So some of the things that we got to see in World Skills Lyon really changed some of the approaches that we're going to try from the Canadian side of things, and the students get to take that back, train that next generation, mentor other people, and kind of build those long-lasting relationships with interprovincial competitors as well as international competitors across the board.
Great, thanks for that, Josh. Neil, my role is skills and looking at skills. What about the skills that the students are learning? What kind of skills would they learn through these competitions and participating in mechatronics?
Yeah, great question, Peter. I'm just benchmarking on my colleague here. It is really essential to teach these students really employable skills. And when we talk about employable skill, I classify it in two levels. One is soft skills and one is technical skills. And it begins with the soft skills. We got to teach them things like critical thinking, time management, even working as a team, because a team of two competes at the mechatronics level. We also teach them it's really stressful as going through the three levels of competition. So we do some stress management as well, and time management, because they have to manage their time very effectively. On the technical skills side, they are actually solving an industry problem. So it's a system. So we teach them systems integration. And when we talk about the word mechatronic simply means mechanical tronics. So it's a bunch of skill sets such as mechanical, electrical, control systems, pneumatics, combined to give that skill set of systems integration. So it's really, really essential that the students are well-rounded. So I do call these are all transferable, employable skill sets. And again, leading to the next part of the question, the competitive advantage, well, I think it does give them a competitive advantage for employment. This is exactly the skill set employers are looking for, and this is a great demonstration of student training with this level of skill sets.
Great, thank you. So that's a great segue for the next question. So Daniel, when I look at that, the skills that, or sorry, the stations that the students are working on, you know, it looks kind of not like a toy or a game, but there is some practical applications to this. So how does this relate to real world, and how do the employers benefit from those skills?
Yeah, so working with the systems that they've been working with when it comes down to these competitions, they're designed to replicate much of the types of processes and systems that you would see in a industrial environment. Things like interfacing with pneumatics, developing user interfaces, programming software, calibrating equipment, calibrating sensors, and it really gives the students an ability to work hands-on with that and demonstrate their ability to do that to a much higher level than what's typically done within a general program.
Great, thanks. And actually, just a quick follow-up question. How do the employers benefit from those skills?
I think the real benefit to the employers when it comes down to this is to have students that have the ability to do everything to a much higher level than, as I mentioned before, they see within the regular program, as well as you can also guarantee that the students that are coming out of competitions such as mechatronics competition have the ability to do all of the things that would be needed to be done in a time-sensitive and highly stressful environment, as can often be seen with things like commissioning of plant or dealing with a production line that has gone offline or something along that lines as well.
Great, thank you. So Michael, we've just heard from 3 Canadian colleges, and you're a representative from Germany, and there are differences in our college system compared to what the educational system in Germany, and specifically your team, the way it's structured is different. Can you kind of explain what those differences would be?
Yes, okay. Thank you very much first to being here with you, with this possibility. Yeah, I listened to you. You all come from colleges, and our competitors here in this friendly competition, they come from the company. They are from Festo, and Festo supports them in their training as a mechatronic technician. And yeah, what's different? We have in Germany this so-called dual system, so where the company and the school, they work very close together. The school do a lot of things of theoretical part that you need. You talk about that. And the company takes over more the practical part. And that is yeah, what we are doing in Germany. And in that play, let's say, the company and the school, they collaborate. So also, if there's a need in the industry, they have to train something special, they give it to the school, yeah, so that they work together on that level. Possibility in this system is the competitors or the trainees, they are employed by the company. So they have a contract with the company, and during the whole process of training, 3.5 years, they have also the possibility to change departments in the company, to know different parts of a company. So it's not only that they learn about what is mechatronics, but they learn also what different parts of departments has a company. Where can I find my job? Where can I place my profession at the end when I'm finished my trainee session? Yeah, and for that, yeah, at the end they get the certificate in this special trade or profession, but they can select, oh, I feel better in support department or R&D department, yeah, or what else, yeah. That is what we are doing here, so that the students can get these practical skills, and in that case they are well prepared for this employer, because they are already in the company, they know the company, yeah, and they give the chance after they finish the trainee to stay with the company for the next years, yeah, and so company has a big benefit from that, and yeah, before they come to a company, also this company says, oh, we need in the future maybe 10 mechatronic technicians. So 3 years before we need them, please let's hire us these young people so that we have young people in the company at the end. Yeah. So that is the role of company and school, and in our case also the company Festo supports this competition. Yeah. So they have the possibility to do a lot of training inside the company when they are there to prepare themselves for the next international skills competition.
Great, thank you. And this is the one reason why I think this is an excellent competition, because we do have Germany and Canada represented, and it's great to have that exchange and understand the differences between our systems, and we can definitely learn from each other on that. So Greg, you represent Festo, or the industry partner. We've heard from the competitive teams and how they benefit students and how it benefits employers, but where does Festo fit in? Why is this important for Festo, and how does it benefit your company?
Yeah, so my name's Greg James. I work for Festo Didactic, which is the educational entity within the Festo group of companies. The Festo Automation Group supplies automation components and solutions to industries such as food and beverage, automotive, machine building, and things like that. Really, when our sales reps are out on the road on the automation side of the business, they consistently hear about this impending skills gap in Canada, specifically in the manufacturing sector. So what benefits us being part of Skills is we're creating awareness for careers in mechatronics, also taking feedback from industry and trying to make it relevant within our competition so that the students are competing on as much leading edge equipment as possible as it resonates in industry. The second point I'd like to make is in Canada we support not only the national team, but we also have 7 provincial competitions in mechatronics, and what this does is it creates awareness for mechatronics in maybe non-traditional manufacturing provinces, and this is really creating an impact in provinces such as Manitoba, British Columbia, Newfoundland, Nova Scotia, with supplying manufacturers that are coming to those provinces with students who have perhaps competed in the skills competition. The last point I'd like to make is at these skills competitions, we often host schools from elementary all the way up to secondary schools. They walk through the competition. They're looking at our college competitors competing in mechatronics and saying, hey, this looks like a great way to pursue a career in manufacturing. And I've seen people that were at the high school level come back and actually compete in a post-secondary setting because of the impact that we had when we were exhibiting at the skills competition. The last point I'd like to make is these competitors become the industry of tomorrow. I'm looking out at Matt from Obsidian Technical. He was a competitor in the 2021 or 2022 competition in Ontario. I think he had a great experience, and he's now out in the industry making an impact. And this is across the board, no matter what we're doing, provincials, nationals, they all get a great experience from competing at Skills, and it's helping us fill that skills gap in Canada. So that's my points.
Great, thanks, Greg. I'm going to open this up to anybody can answer this question. We spent, you see the results of actually months and months of hard work to get the equipment ready and get the competition ready for this Hannover Fair. But there's even more work involved in training the students as well and getting them prepared for this competition or any competition. So I'd just like to throw it out there and ask the question, what is the preparation work? How much time and effort does it take? What do the students go through just to get to the level of competing in these competitions?
Well, I can talk to what our teams typically go through for skills preparation. At SAIT, we typically have a team of 2 that the second year competitor, or the competitor that's typically working on programming, they're in a second year of their program. They've competed typically once as a mechanical expert when it comes down to the team in the years prior. So they end up having 2 years by the time they get to that point, and they train multiple nights a week in between every class that they've got. sometimes weekends as well to come in and train and practice. And then the person working on the mechanical side often is a first year, as they don't have the programming knowledge yet for going on to the programming side of things. And they do the same type of training for their first year of participating in the competition.
I can add to that. Just to take a little bit of a step back, this is a question that's always asked, and I would like to say first it needs support, and we got our president here in the audience, and it's really, really important to have commitment. It really begins with commitment, and secondly, you need a champion. You're looking at a number of champions who's been doing this for many, many, many years. Sir Michael for, I don't know, maybe quite a bit of years. Greg James, 20 plus years, and these gentlemen next to me. So it really begins with a champion. Then you need investment. You need industry support. Industry support is really one of the biggest driver. You need dedicated space and also equipment, relevant, up-to-date equipment. So, you are competing with the best in the world. So you got to have really working with partners such as Festo to stay quite modern. So it's really essential to, these 4 or 5 points I'm making in order to prepare your students for success.
We can move to the next question if you like. So we've heard about the benefits to the students. We've heard about the benefits to industry, as well as the sponsor, Festo. What are the benefits to the schools? So we have a number of schools represented here. So how does a school benefit from these students spending time in these mechatronics, practicing for mechatronics competitions and competing in them?
Yeah, that's a really good question. What we see as the benefit to the schools is that creating that culture at the school of that competitiveness, and something that's not typically like, you go and you see the basketball teams and the other sports teams that are out there, and Dan and I were having a discussion about this a little bit earlier, really trying to develop mechatronics as a team, as that equivalent sports team or skills team that's out there, really kind of gives students and the schools the benefit to understand that culture behind it. Because if you have a good culture, if you're doing it for the right reasons, students want to come in. There's a better drive. You get industry partners who are excited to join, to be part of that. They want to see what's happening. They want to be involved more. And then you get more volunteers, and the more volunteers, the more people you have, the more equipment you get. The more exciting it becomes. And then you get to showcase those skills to people at that regional and international level. So it's really good.
I'm going to follow up one more question, actually. That was a great answer. Thank you. Maybe we'll start with Michael on this question, but definitely everybody can answer.
I cannot say something about the school, but for the next question you will come.
Yes. So we have a very friendly competition here, and that's what we wanted to make sure. It was going to be a friendly competition. We didn't want to have it, 3 Canadian teams against 1 German team. That's not the case. It's actually 4 teams competing against each other in a friendly way. But when we get into competitions, how friendly is it? I mean, is there camaraderie? Is there competitiveness? What is it like in an actual competition?
You are all laughing here. It's fine. Yeah, this is an interesting question. Let me answer it in different. There are different levels of let's see how the air is bristling. Yeah. I think we have to know the start of WorldSkills was really that young people come together in fighting in the education market to show their excellence, to show their competence that they have. That was the basic idea of WorldSkills. So, and that is something what we keep in the competition. So, but of course, the world is bigger, the world changed, and everybody like to be the best and like to go home with a gold, silver, bronze medal. And in such a big competition, where you have mechatronics in Lyon, we had 36 countries from all over the world. You see they have fun, they do their job, they are well prepared, good, but there are also countries say, we are here to fight, we like to get the gold medal. Yeah. So different aspects, countries come with different aspects, they have a different background. But all over, at the end, it is a competition where the competitors make friends. They go home with friends, with new contacts, with new networks. And like we see it here, it's 1 against 3 or 3 against 1. But it's a friendly competition, and they have fun. They bring their result on the floor. They show their competence to us. They show what they learned. They show what they can do in the future. And these young guys are our future. Therefore, it's better to making friends instead of fighting against. Of course, everybody likes to be the best. Also, we here. But we have to make friends.
And I've seen that camaraderie throughout the week, and it's been excellent to see them getting along really well as teammates and competitors. And even I witnessed a special handshake that in the morning when they first get here. It's a very unique way of starting the competition, and it's great, really great to see. Greg, any final words that you have?
Yeah, so just a few final words. I'd first and foremost like to thank NGen very much for making this opportunity possible. It's been a great experience to bring Canadian teams not just to Germany, but to the Hannover Fair, the world's largest trade fair. The students have really we've received great feedback from the students on what a great opportunity it's been. Secondly, it's been a great networking opportunity for not just them seeing world-class vendors, but also liaising with Canadian businesses. So once again, we're trying to fill that skills gap, and just by networking within these types of events, it creates awareness for what we do, which is mechatronics and careers in manufacturing. So thank you, Peter. Thank you, NGen, for making this possible.
Great, thank you, and thank you all for participating in this. And if you get the chance in the next couple of days, please come out and watch the competition. It is really fun to watch. Thank you.